BradLabs.
Data, when correctly gathered from a well-controlled experiment or a reliable source, has the power to answer even the most challenging questions. Learning to read and understand that data can be a difficult task, which is one reason that there are so many different tools to help us do so. From data tables to graphs and charts, each with numerous different subcategories, there are countless ways to organize and absorb data. Each tool tends to be better for some tasks than others, though there are a few tried and true tools that can tackle most tasks we'll need to. Let's look at a few. Pie charts are best used when trying to compare parts of a whole. Line graphs are great for tracking changes over short and long periods of time, like the temperature of water during the freezing process. Bar graphs are used to compare things between different groups, like the sales of various ice cream flavors. Scatter plots are used to determine relationships between two different things. The x-axis is used to measure one event or variable, and the y-axis is used to measure the other. This scatter plot shows the relationship between the amount of peaches sold and their price per pound. In this engineering activity, the goal is to build a barge that can hold as many weights as possible before sinking. We'll use washers as weights. One important consideration to make in this activity is how high to make the walls of the barge. By experimenting with different heights and testing the effects, we can determine the relationship between wall height and the number of washers the barge can hold before sinking. In this case, I tried 3 centimeter walls, 5 centimeter walls, 7 centimeter walls, and I conducted 3 trials for each. Let's see what happened. Here's my data table with all data collected. To help visualize my data, I'd like to put it in a graph or chart. My data does not represent parts of a whole, so using a pie chart wouldn't make sense. A line graph could work, but one benefit of a line graph is seeing change over time, or slight changes between groups. I noticed that my changes are fairly large, so I think the best option would be a bar graph. To start, I will need some sort of medium to graph on. This could be graph paper, a hand-drawn grid, or a graphing program online. Since I'm using paper, I'll also need a pencil and straight edge. I'll start by drawing my axes x and y. Next, I'll mark and number each axis of my graph. The scale of your axes are an important consideration to make. When I say scale, I'm referring to the incremental change between lines of the graph. From one line to the next, does the value change by 1, 2, 5, 10? It's entirely up to you. The way that the graph appears can vary greatly depending on the scale, and the important thing to consider is what scale will make your data clear and easy to read. What is your largest data set? Will it fit on the graph with the scale you've chosen? Counting the horizontal lines, I see that there are 23. My largest data point will have a y value of only 18, so I plan to have a scale of 1 to 1. This means that each horizontal line adds 1 to the y value of my graph, and will look like this. Because this is a bar graph, the scale of the x-axis isn't quite as important. I am choosing to make my bars nice and wide so they're easy to see, and together will take up most of the x-axis. Then I will label each axis. My y-axis will be the number of washers held before sinking, and my x-axis will be the wall height of my barge. I will wait to label the graph itself. That way, I will be sure my label won't be in the way of the actual graph. I plan to average my 3 trials for each wall height. This works particularly well when each trial's data is so close together. If it wasn't so close, I would be inclined to use a scatter plot and plot each trial individually. When plotting my data, I need to be sure that each bar is centered on the x value it corresponds to, and the top of the bar should line up with the y value for that data set. My first data set is 3 centimeters and an average of 9.667 washers. So the bar will be centered on my 3 centimeter mark, and the top of the bar will align with a y value of 9.667. The average for the 5 centimeter wall height was 12.667 washers, and the average for the 7 centimeter height was 18 washers. From here, I can add the title to my graph, color code, and begin analyzing my data. That, however, will have to wait until next week.